In the vast darkness of space, our human eyes can perceive only a fraction of what truly exists. For centuries, we gazed upward with wonder, limited by our biological capabilities. Today, we stand at the threshold of a new era in cosmic observation. NASA has unveiled 20 new images that challenge our understanding of the universe and our place within it. These images were not captured overnight. They represent decades of technological advancement, international collaboration, and the relentless human drive to explore beyond our boundaries. Each frame required precise calibration of instruments designed to detect light our eyes cannot see, to peer through cosmic dust that would otherwise obscure our vision, and to collect photons that have traveled for billions of years across the expanding fabric of spacetime. The first image reveals a stellar nursery we've never seen with such clarity. Within the Carina Nebula, massive columns of gas and dust stretch across light years of space. These cosmic pillars harbor the birth of new stars, hidden from view until now. The energy from nearby massive stars sculpts these structures, simultaneously destroying and creating. They erode the clouds while triggering the collapse that leads to new star formation. What appears destructive is, in fact, creative, a cosmic cycle playing out over millions of years. Moving outward, we encounter a galaxy cluster acting as a gravitational lens. Einstein predicted this phenomenon a century ago, massive objects bending the very fabric of spacetime, causing light to curve around them. Through this cosmic magnifying glass, we can observe galaxies that would otherwise remain forever beyond our technological reach. Some of the light captured in this image began its journey when the universe was less than 1 billion years old. We are literally looking back in time, witnessing the universe in its infancy. The third image brings us to the edge of a supermassive black hole. Not the event horizon itself that remains invisible, but the superheated matter swirling around it, moments before crossing the point of no return. The temperatures here reach millions of degrees, causing gas to emit across the electromagnetic spectrum. The patterns we observe challenge our current models of physics. There are structures we cannot yet explain, behaviors that defy our equations. Each pixel contains a mystery waiting to be solved. What makes these images revolutionary is not just what they show, but how they were captured. Multiple observatories working in concert, each detecting different wavelengths of light. From radio waves to gamma rays, when combined, they reveal a universe more complex and interconnected than we previously understood. Phenomena, once thought to be separate, are now seen as parts of larger cosmic processes spanning millions of light years. Consider the implications. Every scientific revolution throughout history has altered our perception of ourselves. Copernicus showed we were not the center of the solar system. Darwin revealed our connection to all life. Einstein demonstrated that space and time themselves are relative. These new images continue this tradition of humbling revelation. They show us a universe where our sun is but one of billions of stars, in one of billions of galaxies, possibly one of billions of universes. Yet paradoxically, as our cosmic significance diminishes, our intellectual achievement grows. These images represent the pinnacle of human ingenuity, our ability to extend our senses far beyond their biological limitations, to comprehend scales of space and time that dwarf our existence. We are insignificant yet extraordinary, temporary beings capable of understanding eternal processes, physical creatures contemplating the metaphysical. The fourth image in NASA's collection takes us to the aftermath of a stellar explosion. A supernova remnant spreads outward like cosmic shrapnel, enriching the surrounding space with heavy elements. This is not merely a beautiful celestial phenomenon, it is the source of our existence. The calcium in our bones, the iron in our blood, the carbon in our cells, all were forged in the hearts of stars that lived and died before our sun was born. When we look at this image, we are seeing our cosmic origin story. The remnant's filamentary structure reveals shock waves, propagating through interstellar space. Each filament glows with a different color, representing different elements and energy states. The precision of these new instruments allows scientists to measure the velocity and composition of each filament, creating a three-dimensional map of the explosion. What was once a single star has become a complex, expanding structure that will eventually seed the formation of new stars, planets, and perhaps life. The fifth image shifts our gaze to a planetary system in formation, a young star surrounded by a protoplanetary disk, the birthplace of future worlds. Within this disk, we can now discern gaps and structures where planets are coalescing from cosmic dust. The process that formed our own solar system 4.6 billion years ago is happening right before our eyes. The disk contains water, organic compounds, and minerals the building blocks of planets and potentially of life. What makes this observation unprecedented is the ability to detect the chemical composition of the disk with such precision. Previous instruments could confirm the presence of water or simple molecules. These new observations reveal complex organic compounds, including amino acids, the precursors to proteins. The ingredients for life appear to be common in planet-forming regions, suggesting that the conditions that led to Earth's biosphere may not be unique. The sixth image brings us face to face with an exoplanet's atmosphere. For the first time, we can analyze the chemical composition of air on a world orbiting another star. The spectrum reveals water vapor, carbon dioxide, and methane, a combination that on Earth would signal biological activity. Is this evidence of alien life? Scientists remain cautious. These compounds can form through non-biological processes, yet the possibility cannot be dismissed. We may be looking at the first tentative evidence that we are not alone in the cosmos. The seventh image captures the collision of two neutron stars, the ultra-dense remnants of stellar explosions. This cosmic cataclysm releases more energy in a few seconds than our sun will emit in its entire lifetime. The collision creates a kilonova, a burst of light and gravitational waves that ripples through the fabric of space-time. These events forge the heaviest elements in the universe, including gold and platinum. The precious metals adorning human bodies were likely created in such violent cosmic forges. What distinguishes this observation is its comprehensiveness. Previous detections relied primarily on gravitational wave observatories. This event was captured across the electromagnetic spectrum, from radio waves to gamma rays, providing unprecedented insight into the physics of extreme matter. The behavior of matter at such densities cannot be replicated in terrestrial laboratories. These observations become our only window into physics at the edge of our understanding. The eighth image reveals a phenomenon predicted, but never before observed: a cosmic web filament. Cosmological models suggest that galaxies are distributed along filaments of dark matter, forming a vast cosmic web. These filaments have remained largely invisible, detectable only through their gravitational effects. Now, for the first time, we can directly observe the gas within these filaments, illuminated by the light of distant quasars. This observation confirms a fundamental prediction of our cosmological models. The universe is not randomly organized but structured like a three-dimensional web, with galaxies forming at the intersections of filaments. Our own Milky Way exists within this larger cosmic architecture. We are not isolated islands in space but connected to a vast network that spans billions of light years. The ninth image in NASA's collection reveals something unexpected: a galaxy without dark matter. According to our current understanding, galaxies should be embedded within halos of this invisible substance. Its gravitational pull explains the rotation of spiral galaxies and the formation of cosmic structures. Yet here is a galaxy defying this fundamental principle. Its stars move exactly as predicted by Newton's laws of gravity, with no additional unseen mass. How could this galaxy lose its dark matter? The leading hypothesis suggests a cosmic collision, a violent interaction with a larger galaxy that stripped away the dark matter while leaving the visible stars intact. If confirmed, this would provide indirect evidence for the particulate nature of dark matter. It cannot simply be an error in our understanding of gravity, as some alternative theories propose. A modification of gravity would affect all galaxies equally. The existence of this dark matter deficient galaxy suggests that dark matter is real and can be separated from ordinary matter. The 10th image takes us to the edge of the observable universe, a galaxy so distant that its light has traveled for over 13 billion years to reach our instruments. We are seeing this galaxy as it existed when the universe was only 500 million years old, a cosmic toddler still in its formative stage. Yet surprisingly, this galaxy appears more mature than our models predicted. It contains elements that should not have been abundant so early in cosmic history. It challenges our timeline of galactic evolution. The implications are profound. Either star formation began earlier than we thought, or some unknown process accelerated cosmic chemical evolution. Each possibility requires a revision of our cosmological models. What we thought we knew about the early universe may be incomplete or incorrect. These observations push us toward a deeper understanding of cosmic dawn, the period when the first stars illuminated the primordial darkness. The 11th through 20th images form a sequence tracking the evolution of a black hole over time. Never before have we monitored such an object with this temporal resolution. We witness matter spiraling inward, heating to extreme temperatures before disappearing beyond the event horizon. We observe jets of particles being ejected at nearly the speed of light, extending for thousands of light years into intergalactic space. This sequence reveals oscillations and patterns in the black hole's behavior that current models cannot fully explain. The accretion disk flickers with a regularity suggesting underlying physics we have yet to comprehend. The jets change direction slightly, indicating precession of the black hole's rotation axis. Each frame contains data that will keep theoretical physicists occupied for years to come. As we contemplate these 20 images, we must acknowledge both their scientific and philosophical significance. Scientifically, they provide data that will refine our understanding of fundamental physics, stellar evolution, galactic formation, and cosmic structure. They answer questions that have puzzled astronomers for decades while raising new questions that will drive future research. Philosophically, they remind us of our cosmic context. We exist on a small planet orbiting an average star in one galaxy among billions. Yet through our intelligence and technology, we can comprehend the universe on scales that vastly exceed our physical limitations. We are simultaneously humbled by our cosmic insignificance and elevated by our capacity to understand. These images also connect us to future generations. The light captured in these frames began its journey long before humans existed, and will continue long after our species is gone. By observing and recording these phenomena, we create a bridge across time. Future civilizations, whether human or something beyond our imagination, may look back at these observations as the moment when we truly began to comprehend our cosmic environment. In the silence of space, in the cold vacuum between stars, in the unimaginable heat of stellar furnaces, in the unfathomable depths of black holes, there exists a reality that transcends our everyday experience. These 20 images offer us a glimpse of that reality. They remind us that we are part of something greater than ourselves, connected to processes that span billions of years and billions of light years. In understanding the cosmos, we come closer to understanding ourselves.